Hey gang, as I said yesterday, you are kind of doing the reverse of what we've been doing lately. Last couple of days we have had an equation and we are trying to draw the picture of the graph. And today we're going to take a graph and we're going to write the equation from it. So, we are going to start. I have a couple of problems for you guys to look at. It's basically kind of drawing from the same knowledge that you've done the last couple of days in terms of you're looking for single roots, double roots, triple roots, and you're looking at end behavior and what the graph is doing. So if I take a look at this picture that I have right here, I have 3 different roots. I have 3 different times that our graph hits the x-axis. The values are at -3, -1, and 2. And the next thing that you want to do is just look to see what the graph is doing at those places. So at -3, it's going straight through, which means we have a single root. At -1, you're going straight through, which means you have a single root. And at 2, we have that parabola, which means we have a double root. So if I come over here and think about what that looks like as an equation, if I have a root at x equals -3, what that's going to look like in equation is an x plus 3. It's a single root, so I have it to the first. You don't have to write that 1, but you can. A root at x equals -1 will then transform into an x plus 1 factor. And then x equals 2 is going to be an x minus 2, and it's a double root, so I need to square it. And the last thing we want to look at is what the right arrow is doing, because if you remember, the right arrow tells you if you are positive or negative. This is going up, so this graph is positive, so there's nothing I need to write out in the front. And we have the equation. So that's all you're doing is actually kind of going backwards. So let's practice a couple. Three different graphs right here for you. So the first one, we have 3 roots at x equals -3, x equals 0, and x equals 2. So x equals -3 gives us an x plus 3. X equals 0 is going to just be x. Typically, you do tend to write the x first, just so it doesn't get squished between some parentheses. And x minus 2 is the last one. They all go straight through, so they're all single roots. I don't have to add any exponents. And the last arrow, the right arrow, is going up, so I am positive, so I can leave it just like that. Moving on to the one in the middle here, we have a root at x equals -2 and a root at x equals 1. So that's going to look like x plus 2 and x minus 1. Now this one right here is a double root, so I have to add the square to it. This is single, so I can write the 1. I don't have to write the 1. And if you look at what your last arrow is doing, that one's going down. So I have to add in the negative sign out front so that it can go down. And if we do one more, I look at my roots here. I have x equals -4, x equals 0, and x equals 2. So in terms of an equation, I have x plus 4. I have an x, that's the 0, put it out front, and I have an x minus 2. X minus 4 is a single root. This one, here's your triple root now. That's that really weird squiggly thing that we have. So we have x to the third, and then x equals 2 is a single root again. Let's check your arrow. Your arrow is going down, so it needs to be negative. So those are just, we have a picture now, we can write the graph from the picture. So it's very similar to what we've done the last couple of days, but just in reverse. And we can add a little twist to it. If you remember the last couple of days, we have not talked about any stretch or compression factor because we don't have any concern on how high we draw our graph or how low we draw our graph. So What you can do, though, is sometimes if we have another point on the graph, so I'm going to do this problem with you guys. So the fact that I give you another point, it's kind of like what we did with parabolas, where if you plug the vertex in and you need another point, the other point allows you to solve for the A value to see if you are stretched or see if you are compressed. So if I already have this problem right here, let's just say I've already gone through and I found out where I might have my roots are and what my factors would be. If I know this equation is also going through the point 2, negative 42, what that's going to do for us, it's going to allow us to solve to see if we have a stretch factor. Remember, 2 is an x value and negative 42 is a y value. So what I'm going to do is plug in negative 42 for y. Here is the a that I'm solving for. And then every time I see an x, I'm going to plug in 2. Now, depending upon how many factors you have, you might be plugging in 2 a lot. So once I've done that, I need to solve for a. Now, here's your a, and if you follow your parentheses, exponents, multiplying, dividing, adding, subtracting, your PEMDAS that you guys know, if you remember, the first one is p. And what that means is take what's in each parentheses and do that first. So that means take 2 minus 3 and get negative 1. Take 2 plus 1 and get 3. Then take 2 plus 5 and get 7. There are no exponents, so now we move on to the multiply. So what you're going to do is take negative 1, 3, and 7 and multiply them all together, and you're going to get negative 21a. At that point in time, you should be at an equation that you recognize, and it turns out that in this case, we did have a stretch factor. And it turns out, I say it's stretched because it's a number greater than 1, so it's a stretch. So it turns out that this polynomial, I'm so used to saying parabola, this polynomial has a stretch factor. And if I wrote it all together, we can just write it with the 2 out front and then the other things behind it. So let's do one example of that first. We don't need to do both of them. We'll do this first one. So if we have the equation of a polynomial that goes through 4, 40, and has roots at 2, negative 4, and negative 1. Now, this is a little different than what you've seen. It's not off of a picture, but that's where your roots are. So basically, instead of you having to pull them off of the picture, it's just handed to you. So now I can go through and say, well, to start, if I have a root at x equals 2, I'm going to have a factor at x minus 2. If I have a root at x equals negative 4, I have a factor of x plus 4. And the last one will give me a factor of x plus 1. If you don't have another point that your graph goes through, all you can do is assume this equation. But as soon as you're given another point in the problem, that's your indication that you need to find out if there is a stretch or a compression. So once I have all of this written out and I put a in my problem, I can start to solve for a. X is 4, y is 40, so I have 40 equals a. I'm going to go 4 minus 2, 4 plus 4, and 4 plus 1. Now remember, your PEMDAS says do all the parentheses first, so I have 2, 8, and 5. What's 8 times 5 is 40. 40 times 2 is going to be 80. So I have 80a. Divide by 80. And I'm going to get a is, 40 over 80 is the same thing as 1/2. So it turns out we do have a factor out front. It's not a nice polynomial. It has a factor, and it's actually going to be a compression because it is a number between 0 and 1. That follows the same as everything you guys learned in the parabola unit. So if I just combine it all together, I can write the final equation of the polynomial that goes through that point and has those roots. So what you're going to be doing in your homework, it actually has a application problem because the picture is of a roller coaster, and it gives you some information about the roller coaster, and you have to find the equation for what the roller coaster goes through. So that's what I would like you guys to do. There's a small quiz on Schoology for you to do, and then worksheet number 5. And I will see you later.